Okay, this is the product of max terms. Each of the 2 to the 2n functions of n binary variables can be expressed as a product of max terms. To express a Boolean function as a product of max terms must first be brought into a form of war terms. This may be done by using a distributive law, x plus yz equals x plus y times x plus z. Let's see, this is page 59. Let's jot that down. I didn't grab the other formulas yet. There we go. Let me go ahead and bring up my 3D Paint also. Okay. And this x plus yz, again, is just from our properties. Let's see. It's right here. X plus yz is equal to x plus y times x plus z. Keep in mind plus is a or and times is the and. Okay, so here we got xy plus x prime z. Now, when you're talking about that, you're saying, well, that doesn't really fit that same form as this over here. Well, let's take a look at our form. Got x plus yz is equal to x plus y and x plus z. If I label this as my first, now this is my second piece, so I'll label this as S1 and label that as S2. Then we're taking our first plus S1. Then we're taking our first plus S2. Now, this particular problem is xy plus x prime z. Now, different ways you could view it, but how they're viewing this problem here, they're saying this entire piece here is our first. You might say, well, no, it has to be a single variable. No, it doesn't matter, because remember, this just ends up giving you an output anyway, like zeros and ones. And then this would be S1, and this would be S2. So we can rewrite that where we take our xy plus x prime times xy plus z, where we have our first here, we have our S1 here, and we have our S2 here. So when they rewrite that, they're just using the same properties. It looks a little bit different. And then at that point, they break down each one separately. And I know it seems a little bit strange because it's not on order, but remember, they are commutative, so you can flip them around. So I could flip this around as x prime plus xy, and flip this one around as z plus xy. And now if I labeled them, this would be my first, this would be S1, this would be S2. This would be my first, this would be S1, and this would be S2. So this becomes my first, x prime, plus my S1, which is x, and then x prime plus y. This one becomes z plus x, and z plus y. So that's where this breakdown comes from. And then, last thing to note here, this x prime plus x, not x, or x. We got a property for that. This one right here. Postulate 5a says that's equal to 1. And everything else carries down. I think they put them in alphabetical order. Remember what I saw. And that would give us that. Let's see, x prime plus y, x plus z, y plus z. Okay, so function has 3 variables, x, y, and z. Each or term is missing one variable. Therefore, we combine the and of the missing term with its complement to the term where it's missing. Like this first one's missing the z. And let me erase that because I'm out of space, I think. Okay, so I got, what did I have? X prime plus y. X plus z. And y plus z. They kind of broke it into individual pieces here, where they're looking at the x prime plus y first, but we'll do it all at once. So our x prime plus y, we're missing the z, so you can add on z prime. And that's what they do right here. Reason why we can add on z prime is we got a postulate 5b that says x times x and not x times x prime is equal to 0. So by doing this, we're adding zeros. We haven't changed anything. Now the x plus z. the x plus z they have right here, and they add a y prime on at the end. And we'll talk about why it's on here at the end in a second. So I got x plus z plus y prime. So we're missing the y. This one missing the x. So we're going to have x. Let's try that again. Y plus z plus x prime. Now, then they're going from there to this next step where they all of a sudden split this up. And maybe it's not so easy to see where they split, how they split that up, what they're doing. This is our first. This would be S1, and this would be S2. On this next one, although they kind of wrote it kind of funky, this is our first, this is our S1 and S2. And on the last one, this is our first, and this is our S1, and this is our S2. So from our formula, we're going to take F1, which is x prime plus y, and we'll add on a S1, z. We'll have x prime plus y plus z prime. On this one, we'll have x plus z plus y, f plus s1. And we'll have x plus z plus y prime. Then last one, we'll have y plus z plus x, f plus s1. And we'll have y plus z plus x prime. Now they jump directly to putting these in alphabetical order. X, Y, Z, X, Y, Z, X, Y, Z, X, Y, Z. So this one, x prime plus y plus z, x prime plus y plus z prime. This one's x plus y plus z, x plus y prime plus z. This is x plus y plus z. This is x prime plus y plus z. Now when I come down here, we have 1, 2, 3, 4, 5, 6 of them. But when they rewrite that, they just got 4 of them because we get rid of duplicates. So here's an x plus y plus z. There's an x plus y plus z. Here's an x prime plus y plus z, and here's an x prime plus y plus z. Which leaves us x prime plus y plus z prime. Oh, I forgot that one. Let's try it again. X prime plus y plus z, and x prime plus y plus z prime. This one, x plus y plus z, x plus y prime plus z. And I already wrote out this duplicate down. I already wrote this duplicate down here. So those will be our 4, assuming my eyes haven't crossed. Now, once we get in that form, where we've got a product and everything inside is addition, or in terms of I got ands, and then everything inside is ors. Then we can rewrite that in terms of our max terms. Then it goes back to here. X prime plus y plus z. x prime plus y plus z is M4, big M. X prime plus y plus z prime, x prime plus y plus z prime. That's right here, that's M5. X plus y plus z is up here, that's M sub 0. And then x plus y, y prime plus z. X plus y prime plus z. There's M2. Hmm. 2, 0, 2, 4, and 5. 0, 2, 4, and 5. They put in order, which should be, it's my next step. Now they got a different notation for this. Another convenient way to express this function is as follows. You got this symbol right here. And then your different subscripts off of that, 0, 2, 4, and 5. This is the product. That says to multiply these together. So you've seen this right here already. That's where you add them. This is where you multiply them. Let me grab a drink. Is there any questions on that example? Okay. Now converting between the canonical forms. Complement of a function expressed the sum of minterms equals the sum of minterms missing from the original function. This is because the original function expressed by those minterms makes the function equal to 1, whereas its complement is a 1 for those minterms for which function is a 0. As an example, consider the following function. We got our function in terms of a, b, and c. Comes out as the sum, the minterms, of 1, 4, 5, 6, and 7. Excluded from that is 0, 2, and 3, and I guess that's it. So the function as a complement can be expressed as follows. Complement of that, there it is. Complement of a, b, and c is equal to 0, 2, and 3 added together. And again, that notation implies adding together your minterms. M sub 0, little m sub 0, m sub plus m sub 2 plus m sub 3. Now, if we take complement of f prime by De Morgan's law, we obtain f in a different form. I don't think that's in the exactly in this form. Oh yeah, here it is. Adding them together, taking the prime. You rewrite as multiplication and take the prime of each one separately. So that's why these added together, taking the prime of it, you take the prime of each one separately. Now, when you do that, then the equivalent of that is that this becomes little m sub 0 prime becomes big M sub 0 in M2 and M3. So that gives us the product 0, 2, and 3. So real easy to convert them. If you got your minterm, then the product of the max terms is just the missing numbers. Okay, and then m sub little j prime is equal to big M sub j. That is a max term with subscript j is a complement of the min term, the same subscript j, and vice versa. Does that kind of make sense on those? Okay. Now here, a Boolean function can be converted from an algebraic expression to a product of max terms by means of a truth table and the canonical conversion procedure. Consider, for example, the Boolean expression xy plus x prime z. First, we derive the truth table, and they skip a lot of information there. Let me put that in. So f is equal to x and y, or not x and z. Okay. 1, 2, 3, 4, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. And what's this pattern last one? 0, 1, 0, 1. Okay. Well, we need a column x and y, x times y. So 0 times 0 is 0, 0 times 0 is 0, 0 times 1 is 0, 0 times 1 is 0. 1 times 0 is 0, 1 times 0 is 0, 1 times 1 is 1, 1 times 1 is 1. If we had our x prime, that's not x, so it flips all these x values. So I'm going to have 1, 1, 1, 1, 0, 0, 0, 0. In our column, x prime z. X prime is this one right here, and z is right here. So I multiply those together, or AND them. 0 times 1 is 0. 1 times 1 is 1. 0 times 1 is 0. 1 times 1 is 1. 0 times 0 is 0. These would all be zeros because these are all zeros. Okay. And then we've got xy plus x prime z. This is our function. This is f. So I'm going to add these with our stipulation of the special add we have to do. 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 0 is 0. 0 plus 0 is 0. 1 plus 0 is 1. 1 plus 0 is 1. Assuming I didn't get off, I should match this. 0, 1, 0, 1, 0, 0, 1, 1. Okay. Now notice what it's pointing out is once you get to that point, your min terms are your ones. So that's our min term, min term, min term, and min term. And these are your max term, where it's 0. So for our min terms, we got 1, 3, 6, and 7. Well, where does that come from? Remember this over here corresponds like our first one here is 1. This corresponds to 2 squared, 2 to the first, 2 to the 0, or 4, 2, and 1. So this min term here is m sub, not m sub 0, it's m sub 1. That's little m. That's where they get this first one. This next one, 3. This is 2 plus 1. I'm using these numbers down here. So this is our little m sub 3. This next one right here is 4 plus 2 is 6. That's little m sub 6. And this next one is 1's all the way across. 4 plus 2 plus 1 is 7. So that's little m sub 7. So that's where we get 1, 3, 6, and 7. Now, they talk about the prime is all the numbers that are not included in there. This is our f. And our f prime is 0. 2's missing. 3, 4, 5 are missing. 6, 7 doesn't go up to 8. So that's where they would have got the 0, 2, 4, and 5. Now the complement matches our product over here, product of the max terms. So f is going to equal to the product of 0, 2, 4, 5. Now what you'll find is that any function can be written as either the sum of the min terms, product of the max terms, so forth. Okay, let's that one's pretty easy. But let's explain where they came up with these items. Grab a drink again. Okay, what do we start out with? F x, y, z is equal to the min terms. 1, 2, 3, 5, and 7. So we're right in terms of the max terms. What's missing is a 0, 1, 2, 3, 4, 5, 6. So it's missing 0, 4, and 6. And that's where it's getting the 0, 4, and 6 out of here. Now this corresponds to m sub 0. This corresponds to, and these are big m's, m sub 4, and that corresponds to m sub 6. What am I on? Page 61? Using our table, m sub 0. M sub 0 is right here. It's x plus y plus z. M sub 4 is right here. X prime plus y plus z. And m sub 6, which is right here, is x prime plus y prime plus z. which is where they get this at. So x plus y plus z, x prime plus y plus z, x prime plus y prime plus z. Now this is going the other way. Here we're starting out with product. 1, 3, 4, and 6. 1, 3, 4, and 6. This can be rewritten as a sum of the missing ones. 0, 2, 3, 4, 5. Yeah. Wait a minute. Missing one. 0, 1, 2, 3, 4, 5, 6, 7. There's supposed to be 8. That's why I counted. It's like, oh, I'm missing one. These correspond to little m sub 0, little m sub 2, little m sub 5, and little m sub 7. And let's see. Little m sub 0 is x prime, y prime, z prime. X prime, y prime, z prime. Plus m sub 2 is x prime, y, z prime. X prime, y, z prime. 5 is x, y prime, z. And number 7 is x, y, z. So again, we can just look them up in the table. Okay, right here. X prime, y prime, z prime plus x prime, y, z prime. Okay, x, y prime, z, yep, and then x, y, z. Does that make sense? Okay. Now here it says identify the min terms, max terms of the true table for f shown below, and comes on down here, tells us our min terms are 1, 3, 4, and 6. If I look at the 1 here, keep in mind that this is 4, 2, and 1. 2 squared, 2 to the first, 2 to the 0. Then this would be little m sub 1, which is where they came up with this one right here. This one right here, this would be 2 plus 1, that's 3, that's little m sub 3, which is where I came up with that 3. This one here, nope, that's one I just looked at. This one, got a 1 here, 0, 0, so that'd be 4, so that's little m sub 4. And for this one here, I would have 4 plus 2 is 6, so that's where they came up with 6. Now just a quick example. I'll make up. Two, three, four, one, 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 one. 0, 0, 1, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0, 1. And I got my function. I've gone through, built my truth tables, columns and everything, and I come up 1, 1, 0, 1, 0, 1, I don't know, 1, 0. So I come up like that. Well, keep in mind this is 4, this is 2, and this is 1, and we'll use that to figure out which one of these is. Here's a 1, so that's 0, so that's 0. This one has a 1 here, which means I take 1 times 1, that's 1. Here's a 1. Again, I'm looking at these right here. This one has a 1 here and a 1 here, so I add numbers together in those columns. 2 plus 1 is 3. Here's another 1. I got a 4 here, plus 1 is 5. Here's another 1. I got 4 plus 2, which is 6. And I don't need to do the products just because I know it's by default the missing ones. 0, 1, 2, 3, 4 is missing, 5, 6, 7 is missing. And there's 8 of them now. So that would be my answer. The most tedious part is coming up with this final column for F. At that point, it's pretty easy to see what about the min terms and max terms. Okay, standard forms. The two canonical forms of Boolean algebra are basic forms that one obtains from reading a given function from a truth table. These forms are very seldom the ones with the least number of literals, because each min term or max term must contain by definition all the variables, either complemented or uncomplemented. Another way to express Boolean functions is in standard form. In this configuration of terms that form the function may contain 1, 2, or any number of literals. There are two types of standard forms, sum of products and product sums. The sum of products is a Boolean expression containing and terms called product terms with one or more literals. The sum denoting the oring of these terms. An example of a function expressed as sum of products is given by this one. So again, the products means that each one of these is multiplied together or ANDed. This is ANDed. This is just one, so doesn't really fit that, but I mean it is by times 1 if you think of it that way, and then there's a plus between them. The expression has 3 product terms with 1, 2, and 3 literals. Their sum is an effective OR operation. So here we show the sum of the products. We got y prime coming in by itself, and it's all coming into a big OR gate because there's pluses between them. Now here we got x prime, y, z prime. And I'm not sure why they kind of switched orders. Doesn't really matter. But that's this last here, these 3 literals. And these are AND gates that they're going into. So not x and y and not z. This one's x and y, which is our x times y. And then go into that and gives us our F1. Now, if we went through and found the product of sums form of that, then we'd have this. So we'd have x, y prime, or z, that's the OR. And the y prime, of course, is not y. This is not x, y, and not z. Oh, they're different. Okay, I was gonna say how they switch from that. Those don't match in terms of that. This is F2. Let's see. This circuit configuration is referred to as two-level implementation. It means you have a level of ands and then or. In this one, you have a level of ors and then ands. So that's what they mean by two-level implementation. Now, a product of sums is a Boolean expression containing or terms called sum terms. Each term may have an a number of literals, and then there's a product denoting the ending. So it's saying you can have one literal, two literals, three literals, four literals, however many. They're connected by a plus or an or, just like these are connected. Or if it's a single literal, like that, it doesn't, of course, have a plus. And then you're multiplying them all together or anding them. So this expression has three sum terms with 1, 2, and 3 literals. Product is an and operation. Use of the words product and sum sounds to a similarity to the and operation to the arithmetic product multiplication, and similarity to the or operation to the arithmetic sum addition. Gate structure of the product sums expression consists of a group of or gates for the sum terms, followed by an and gate. This standard type of expression results in two-level structure of gates. X is coming in here. Then there's not y and z. Not y and z are coming into this or, that's a plus. And then not x plus y plus z prime, that's our or coming into or, not x or y or not z. And then they're all coming into the and that's what these three multiply together. Now here, this is in a form that's not our standard form, because remember our standard form has the two levels there. Is neither in sum of products nor in product sums. The implementation expression is shown in figure 2a, so it's down here. So we got our a and b, that's that part. Down here we got d or e, that's d plus e. And then we got c and d or e, so c times d plus e. So that c is coming in, d plus e is coming in to an and gate, so they'll be multiplied together. That's coming out here. This is coming into here to one big or, and based upon a, b, and then c times d plus e. So that's the implementation there. There are three levels of gating in this circuit. It can be changed to standard form by using a distributive property to remove the parentheses. Even though we know what the distributive property is, that's possibly 4a here. Remember, if you got a single item in front of your parentheses, it's like you multiply it together like algebra, x times y plus x times z. So here to multiply c times d plus c times e. So we'll have an a and b, we'll have a c and d, we'll have a c and e, and then all three of those coming in. And so we took it down to two levels again. Okay, practice exercise 2.10. Trying to think the best way to do that. I'd have 16 items in my table. So I could do a truth table, or I could add the missing variables in. I don't know which way would be shorter, to be honest. Let me add the missing variables in. since it doesn't really indicate how to find your answer. I think either way it'd be kind of nasty. F equals A plus B prime C plus AD. Now we got 4 variables. So on this one, we're missing the B's. So we got B plus B prime. We're missing the C's. We got C plus C prime. We're missing the D's. We got D plus D prime. Now for this next one, we're missing the A's. So we got A plus A prime. We're also missing the D's. So we got D plus D prime. And our last one, we're missing the B and C. So we're going to have B plus B prime and C plus C prime. Okay, so A times B is AB. A times B prime is AB prime. And C times D is CD. C times D prime is CD prime. C prime times D is C prime D, and C prime D prime. So my eyes haven't got off. In this one, B prime C times A is A B prime C. B prime C times A prime is A prime B prime C times D plus D prime. AD times B is A B D. AD times B prime is A B prime D times C plus C prime. Okay, A, B, C, D. I'm just foiling. A, B, C, D prime. A, B prime, C, D. A, B prime, C, D. A, B prime, C, D prime. A, B prime, C, D prime. Geez, I got some more here. Okay. A, B, maybe the truth table would have been easier. A, B, C prime, D. A, B, C prime, D prime. A, B. Oh, that's a nightmare. Okay, let's go to the truth table. Just basic algebra, but I just can't seem to handle that, I guess, this morning. Okay, so A, B, C, D. We have 16 possibilities, so it goes down to 17, I guess. So 0, 0, 0, 0, 0, 0, 0, 0. Is that 8 of them? 1, 2, 3, 4, 5, 6, 7, 8. 1, 1, 1, 1, 1, 1, 1. And then 0, 0, we'll have 4 of them. And then 4 ones. 4 zeros. 4 ones. Here I have 2 zeros. Oops. Let's try it again. 2 ones. 2 zeros. 2 ones. 2 zeros. 2 ones. 2 zeros. 2 ones. And then this alternates. 0, 1, 0, 1. After you see a pattern on these aren't too bad. then our function is I need to find B prime C. So B prime be 1, 1, 1, 1, 4 ones. I'm flipping B's. 4 zeros. So 4 ones again. And 4 zeros. B prime C. So now I'm going to multiply column E by column C. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 0, 0. I think I'm screwing up. Okay, 0, 0, 1, 1, 0, 0, 0, 0, 0, 0, 1, 1, 0, 0, 0, 0. Okay, so then I need AD. So I'll be multiplying this column by this column. Okay, 0, 0, first 8 are zeros, I guess. 5, 6, 7, 8. Then 1 times 0 is 0, 1 times 1 is 1, 1 times 0 is 0, 1 times 1 is 1, 1 times 0 is 0, 1 times 1 is 1, 1 times 0 is 0, 1 times 1 is 1. Then we want to add together A plus B prime C, and I'll do it by pieces. A plus B prime C. Okay, A. I guess I already had A. B prime C. Do this one. I'm going to add them together. 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 1 is 1, 0 plus 0 is 0, 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 1 plus 0 is 1, 1 plus 0 is 1, 1 plus 1 is 2, so it's 1. 1 plus 1 is 2, so it's 1. 1 plus 0 is 1. 1 plus 0 is 1, 1 plus 0 is 1, 1 plus 0 is 1. And then last, A plus B prime C plus AD, I'm assuming. Okay, so it's these two columns. Okay, I don't have to highlight those. 0 plus 0 is 0, 0 plus 0 is 0. 0 plus 1 is 1, 0 plus 1 is 1. 0, 0, 0, 0. 1. 2 plus 2 is 1. 1. 2 plus 2 is 1. 1. 1. 1. 1. Keeping in mind that this is now 8, 4, 2, and 1, then the ones here will tell us what to add together. So I got ones here. Okay, so 0, 0, 1 here, that's a 2, so this would be M2. This one, that's 8, 4, but those are zeros, so this would be 2 plus 1 is 3, so that's M3. This one, just a 1 here, so that'd be M8. This one I got 1, 0, 0, 1, so that's 8 plus 1 is 9, so that's M9. I'm out of time. 2, 3, 8, 9. And then if I went through, that's where I get the rest. Does that make sense on that practice exercise 2.10? Okay, just tedious. I don't think, it's either brute force trying to do this or truth tables, but either one is just mind numbing. It gets you there though. Well, we'll go ahead and stop there.